These CSSTP proofs from yesterday are going to make them one step longer. Okay, so prove the triangle similar, CSSTP, one more extra step today. Other than proofs, this whole unit's pretty much been dedicated to solving a proportion. How do you solve proportions again? Cross multiply. And all unit, here's what I've been saying. You multiply these. Well, these have a name. All right. Whatever's in these two spots in a proportion when you cross multiply, they have a name. All right. And I want to make sure we're good with the vocabulary now. That name is called the extremes. Those are the extremes of a proportion. All right. Whatever's in those two spots are referred to as extremes. And yes, it's pretty corny. The only way I remember those are called extremes is I think of extreme downhill skiing. I don't care if you don't like it. All right. Make something up yourself then. All right. I think of extreme downhill skiing. And when you multiply the other two, these two here, they have a name in the proportion. Those are called the means of a proportion. Means. All right, those are your means. All right, so when we multiply the extremes, when we multiply the extremes and the means, what do you guys do to these two? You just leave them hanging? You set them equal, right? All right. And that's the theorem I'm going to put today, except I'm going to put this fancy vocab with it. When you add two numbers, that's called the sum. What happens when you multiply two numbers? That's called the product. All right, so here's our new theorem. The product, meaning we're multiplying, of the means, the product of the means equals, you want to finish it? What do we set it equal to? Product of the extremes. Look at you guys. Product of the means equals product of the extremes. Now I know because we've done CPCTC and CSSTP. I know some of you are probably thinking, "Oh boy, I hope there's a shorthand. That's a lot to write." No, there's not. Sorry, there's not a shorthand. That's what we write in the proof when it's time to write it. All right. If I see anybody put POM equals PO, all right, as an abbreviation, all that's going to get you is a free headlock. All right, that's all that's getting you. Sorry. Okay, there is no abbreviation for this. We write it all out. All right. Okay, so let's use it now. Let's use it. Ooh, how about that proof statement in the first one? I'm asking you to multiply segments. All right, so this is going to be a means and extremes proof. We're not even going to sniff means and extremes until we have similar triangles. All right, we need similar triangles, so I do have means and extremes. And in this diagram, just like yesterday, there's a lot of triangles there. Which two do we need to prove similar? I'm going to tell you the same thing I said yesterday. Look at the proof statement. The proof statement will tell you what triangles to prove similar. The first line, let's see, the first side is ER. Oh, all right. I think I got the first triangle. All right, there's only one triangle that's got ER as a full side. ER, T. Ooh, watch what happens next. Lock in here because this is the first time this is going to happen. It didn't happen at all yesterday. Next side is AD. Hey, look at that. That still does not help me with the second triangle, does it? Because it could be ADT or ADR. So that's the first time that happened. No big deal. Keep looking at the proof statement. Next side, TE. Oh, I already got that. I already highlighted that. All right, I'm still waiting for the second triangle. Look at the final side, DT. Okay. I think we got the second triangle now. ADT. And what's our only method when we're doing a proof anyway, to prove these two triangles similar? Angle. There's other methods, but when we're doing a proof, it's probably going to be angle. And let me tell you, something must have happened this morning. Some of that ice must have melted away from my heart because look at that. I already gave you the right angles. You don't even need to tell me why. Soft. I'm getting soft. That's what's happening. You don't even need to say altitudes or perpendicular lines form right angles. They're already right angles. You're welcome. All right, I'll let you sniff around here a little bit, and I'll ask somebody in a minute, give me a pair of angles that are congruent, because I need angle. All right, what do you got for me? Give me a pair of angles that are congruent. Leading to angle sooner or later here. Whoa, what happened there? Uh-oh. Oh boy, what am I going to do now? This is not good, kids. This is not good. How about a little refresh, maybe? Whew, this is not going to be good. What is he going to do without the numbers? Oh boy. Come on. All right, this is fun. There we go. I know you're going to be devastated. Oh, yeah, there we go, Cormac. Crisis averted. So sad, kids. So sad.
Angle R equals angle ATD.
Thank you. You can call it angle R. I like that. But you are going to have to use 3 letters, ADT on the other side. Nice work. So let's get that down. Angle R congruent to angle ATD. How does Cormac know those two are congruent? What theorem is he using to say those are congruent? Bailey. Look at your givens too.
Congruent sides are across from the angles? Because it's isosceles?
In a triangle.
In a triangle.
Yes, that is true. In a triangle. Congruent angles. Again, you can use congruent sides first. I don't care. Congruent angles are across from. Congruent sides. All right, there you go, kids. There's one angle down. Where's the second pair? Don't overcomplicate things. Please don't overcomplicate it. Where's the other pair of angles that are congruent? Shar? The right angles I already given you. TER, congruent to ADT. All right angles congruent. Good job, everyone. Now we have angle, so go ahead, prove those triangles similar. Let's see, triangle ADT. Similar, if I go ADT, I gotta go TER, I guess. Everyone have a nice helping of self-respect this morning? Do you have the congruent sign or the similar sign down there? Come on, one jab. One jab. All right, now, where do we go from here? Do I go right to the proof statement? No, I can't go. If I'm going to go to the proof statement, I need means and extremes first to be able to cross multiply. I don't have any means and extremes. You now need to build means and extremes. Show me what sides are in proportion. Oh, God, how am I going to match up the sides now? You don't have to worry. Don't look at the diagram. Do not look at the diagram to do this. Look at the proof statement. The proof statement will tell you how to make your proportion. You have to cross multiply ER and AD. All right, if it's asking for ER times AD, you either need to put those two as your means or your extremes. All right, if I put ER here and then AD here, there's no way they're going to get multiplied like that, right? Everyone agree? They have to be means or extremes. So I'll put, here you go, AD here. That's the only place I can put it, so it's going to be multiplied. And then TE and DT can go in the other two spots. Make sure you are multiplying them. And then from yesterday's class, why is this proportion true? Woo, 3 spot, Stellan. Oh boy. You got notes from yesterday you can look at. After the triangles are congruent, why are the sides in proportion?
Once the triangles are proven congruent, they're also similar.
What?
Is that not a form theorem?
It is, but it's a way to prove
Oh.
triangles similar. I'm looking for, after I prove triangles similar, why are the sides?
Oh, they're in proportion.
Yes, why?
So corresponding sides of similar triangles are in proportion.
And we had an abbreviation called?
CSSTP.
All right, there we go. We got it.
I got through it.
Yep, you did. Yep, that was painful, but you did. Yep, good job. Now we're making it one step longer. All right, this is where we ended the proof yesterday. You make it one step longer now. You multiply your means and extremes. ER times AD equals DT times TE. Product of the means equals product of the extremes. And yes, somebody asked in my last period class, can you interchange means and extremes? Yeah, sure. Go ahead. Product of the means equals product of the extremes. So see, it's a 3-step process. Triangle similar, CSSTP, then your means and extremes. It's a 3-step process here at the end. All right, I'm done talking. You guys in your groups, or if you feel like you want to do it by yourself, go ahead. I'm going to give you guys about 5-6 minutes here to do the next proof. And as you guys can see from the proof statement, it is a means and extremes. So first thing you might want to do, what 2 triangles am I going to need similar to show those means and extremes are equal? So go ahead, 5-6 minutes. Don't waste your time, please. Oh, we got to get something down here. I don't want to have a staring contest with you in the proof. Highlight the triangles you need. And then now they're going to get 2 pairs of angles. You know your parallelogram properties pretty well. Another minute here. All right, let's talk. Here we go. First, let's make sure we had the correct triangles that you needed to prove similar. All right, it was the big one here, RCQ. Make sure that was one of two triangles you had. RCQ needed to be proved similar with APQ. Okay, so those two are the ones that needed to be proved similar. All right, so how do I get angle? I'll show you all three pairs. Just make sure you had two of them. Because it was a parallelogram, opposite angles are congruent. So that could have been one pair. Parallelogram implies opposite angles congruent. The other pair had to have been an alternate interior pair. Right, had to be. So here are the two choices. First choice, RQB, congruent to BAP. Those were a pair of alternate interiors. Now, if you have those in your proof, you also, before that, you had to say that RQ was parallel to, what's that letter there? Anybody? SP. Parallelogram implies opposite sides parallel. Now look, what have we been saying all year about this? Not all year, but since last unit. Put both pair down, right? Put both pair. You can't go wrong if you put both pair down. If you're ever worried about what lines you need parallel to say these are congruent, put both pair down. Or, where's the other pair of alternate interior? Angle C down here, congruent to angle BQP. That's the other pair of alternate interiors that you could have had. So what I have labeled up here, you should have 2 out of the 3. And you definitely should have had opposite sides parallel in the parallelogram before saying any of the alternate interior are congruent. Okay? And then from there, don't compare your proof to mine. I put all 3 pairs of angles just so you could see what it looked like. All right, I got the opposite pair. I got both pair of opposite sides parallel, the alternate interior. All right, and then take a look. Angle. Please look at your proportion right now that you wrote. Look at your proportion in CSSTP. Are you cross multiplying QC and QP? Make sure you are. All right, because if not, you got to rewrite that sucker. And are you cross multiplying AQ and CR? Okay. Look, if you had like 2 steps down, we need some help. All right, we need some help if you only had 2 steps down, or maybe 3. We need a little help here. All right, I don't know what else to tell you if we're just staring at this and we don't see the alternate interior angles or the opposite angles. All right, get some help. Questions? All right, we're rolling. Midterm review packet. Let's go. Review 7, just where we ended yesterday. Review 7. Remember, if you weren't here for my announcement, we're in the cafeteria, and your seat numbers are on Google Classroom. All right, I think we ended class. I wanted to do problem. We did, yep, problem 9. Here we go. Problem 9, everybody. Yep.
There's an extra packet. I didn't get them.
Right over, should be over there underneath the Unit 7 packets. All right, so here we go. Write the equation of a line. All right, if I'm going to ask you guys on the midterm to write the equation of a line, there's two things you're going to need to do it before you tell me the answer. What are the two things I need to write on a line? Two things I need. Slope is going to be one of them. Yep. I need to know what the slope of that line is and there we go, y-intercept. Slope is what's called the m value. Remember y-intercept, what letter? B. There we go. All right. So I need your help finding those two. You got to find the slope first. Can't find the y-intercept without the slope. All right. So how do I get the slope? Let's keep reading. Perpendicular. Perpendicular, and we're looking for slope. So what comes to mind? Same or negative reciprocals? Okay. Negative reciprocals. So look at the line I gave you. Y equals negative 2x plus 4. Negative 2 or 4, which one's the slope? Negative 2 or 4, which one's the slope? Negative 2. So if negative 2 is my slope and I need its negative reciprocal, what's going to be the slope of my line I need to write for an answer here? Negative 2, you just told me was the slope, which is correct. But I don't want to write negative 2 down in my answer. I want the negative reciprocal. Flip and change the sign. What's the new slope now? Flip and change the sign. My new slope? Positive 1/2. All right, so we got the slope down now. The slope is completed. How do I find the y-intercept? Here we go, a little review from Unit 4, I think, or 3. We use this equation, y equals mx plus b, to get the b value. You're going to plug in everything but b. So what the heck do I plug in for y? Well, what y coordinate does it go through?
13.
Negative 13. So that's what I plug in for y. M? Ooh, which one do I use? Negative 2 or 1/2? Remember, you're finding the y-intercept of the line we're looking for. So I should be using 1/2 for my m times what x coordinate does it go through? Negative 4. And now you guys are solving for b. Using a little algebra to solve for b. Might need use of your calculators here. Let's get going. I'm not going to spoon feed you this stuff. No curve on this bad boy. You are on your own. Negative 11 for the b value. All right, you have your slope, you have your b. Now write the equation. Write the answer now. Y equals, our slope was 1/2. Make sure you put the x there. All right, can't give credit without the x. And then minus 11. Only follow-up question I have here before we move on. What if I change that word perpendicular to parallel? How does this problem change? I'm still going through all the same steps. All the same steps, except that wouldn't be 1/2 anymore. What would it be if I asked for a line parallel? The same slope, negative 2, correct. So if I change that word to parallel, I'm using the same slope, negative 2 throughout. All right, one more here I want to do with you. 10, little partition action. Oh boy, how the heck did we do those? Huh. Well, first thing, I will provide a scrap piece of graph paper on the back of your midterm on game day. Use it. I want your partition questions to be graphed, please. All right, so please go ahead, do a quick graph of AB. Reason I want it graphed, it's not going to be required, but the reason I want it graphed is whatever our answer is, it better end up on AB. All right, your answer should not land anywhere off of AB. It should land somewhere on AB. All right, let's slow it down a little bit and review how do I do partitions. So the first thing we're going to do is find its x coordinate. All right, what's the x coordinate of this point? How far away are the x coordinates of A and B? That's your first job. How far apart are the x coordinates of A and B? All right, so now I'll start asking questions. How far apart are those x coordinates of A and B? How far apart are they? Jonathan?
9.
They are 9 units apart. Now I look at my ratio, which is 1 to 2. 1 segment to the left, 2 to the right. So how many equal parts do I need to break it up into eventually? 3, right? 3 equal parts. So that's why I asked, because that's what we're dividing 9 by. Take those 9 units and divide it into 3 equal parts. And that tells you, now what does that 3 mean? Every time you break it up, you go 3 units. Then you go another 3. Then you go another 3. All right? All right, well, how many times do I have to go 3 units? Once, twice, or all 3, right? What's the first number in the ratio? 1, right? So I only have to go, watch, 3 units 1 time. If there was a 2 there, I'd put a 2 there. But I only need to go 3 units 1 time, so 3 total units. All right, that tells me I need to go 3 total units from wherever I started from. All right, next question for somebody. Where did I start? What x coordinate did I start at? Bryson, where did I start?
-4.
Okay, so starting from -4, I'm going to go 3 total units and see where I end up. So I end up at -1. I think. We'll check it at the end. We'll check it at the end. All right, x coordinate down. Now let's do the same steps for the y coordinate. There is a little catch for the y coordinate though. So for the y coordinate, go ahead. What's the distance between the y's now? Distance between your y coordinates. Henry?
6.
6. All right, here's the catch. Notice where we're going? We went from 1 to -5. We're going down, right? So if we're going down, I'm going to put a negative there. That not to say it's -6, because we can't have a negative length, just that we're going down 6. All right, we're going down 6. Still divided by, how many equal parts again? 3. That doesn't change. So now, every time we move, we're going to move down 2 units every time. All right, well, again, how many times do I need to move down 2 units? Look at your ratio. We always go by the first number. All right, what's still the first number there? So I'm going to go down 2 units 1 time still. All right, I'm never going to use that number on the right. So we're going to go down 2 units total. And final question here for somebody. Where did I start on the y-axis? Where did I start here? Drew, where did I start?
1.
At 1. So 1, and I'm going to go down 2. So I should end up at -1. So let's check. I think my point that I need is -1, -1. Go back to your graph. Is that point on my line? Yeah. And also, not only is it on the line, look at what my ratio was. 1 to the left, 2 to the right. So that part to the right should have been a little bigger, which it is. That's why you have to graph. Because the biggest mistake's going to be, you forgot the, let's be honest, you're going to forget the negative, some of you. All right? But at the end, you're going to get a point somewhere up here. Something went wrong. Your point has to land somewhere on your line segment. That's why I want you to graph the darn thing. Questions there? All right, tomorrow we're going to do that proof. We definitely don't have time to do the proof now, so go back to your Unit 7 assignment and start it for tonight.